Hello, and today I'm going to work with you on section 1.6, other types of equations. And I'm sorry for the title, but that's how they've always labeled this chapter, or this section of this chapter in the book. Remember, we're studying equations in chapter 1, just different types of equations. So far we've studied two main categories. We studied the linear equations, where x is to the first. Then we studied the quadratic equations, where x is to the second. Those are the two main types of equations you see, or at least try to break it down to see in our algebra text. But there are these other types of equations that come up here and there. So that's what we're addressing in 1.6, kind of the other things that can come up, sticky situations to deal with it aren't just do this one thing all the time. Okay, so the first type we're going to see is on example 1, and I'm on page 136, is when you have fractions in your equations. Now, we've already seen fractions in the linear equations, and we know that we always clear a fraction when we see a fraction by timesing through by the LCD. So, but this one's a little more up a notch because it has variables in the denominator, so we have to think a little bit more abstractly about that, but it's still the same concept. Find the LCD. Keep in mind this last thing is over 1, so the LCD is one of each type of factor and where it's at the most, because you need at least one of everything in the denominator, and then if it's there twice, you're going to need 2 of them because everything has to fit into it evenly. The least common denominator is the least thing all of the denominators fit into evenly. So in this one, we just need one of these and one of these. So we'll need a 3 and an x minus 1. And we times that to the left side, and we times that to the right side. Timesing or multiplying is distributive, so it distributes into every term, thus getting rid of the fractions. This first fraction, the 3 part cancels when you distribute, again because you are multiplying, diagonals cancel in fractions, and then you multiply what's left. So it look like that. Then we distribute onto the next fraction, bringing us back to our full LCD, which is a 3 and an x minus 1. When we times it onto the next fraction, the x minus 1 parts cancel, so we have 3 times 2x, or negative 6x that's left. We times the part that's left on top together. And the denominators canceled out, so we don't have a fraction any longer. Lastly, there's nothing here to cancel, so it's all of that times together. I would put the 3 and the x in that order, although that's not critical, but it looks more natural. So now we have an equivalent equation, but just no fractions in it. So then we go through our cleanup, and we would FOIL this, bring down our other terms, distribute on this side, and I see x squared terms, and that's what makes me think it's a quadratic. So I've got a 3x squared on the left, a 3x squared on the right. Those are just going to cancel each other out. They're the same weight, so you can just drop those off, or you can think about if I brought that over, they would cancel each other out. So that it actually looked like it was going to be quadratic, but it is not because the squared part canceled out. So then I combine the other like terms. A minus 1, a minus 3, and a minus 6 would be minus 10x and a 1. Then I can go either way with my x's. I would probably prefer to bring the minus 10x to the right as a plus 10x, and then combining is 7x equals 1. Dividing both sides by 7, and then we get to one solution, 1/7. One thing to watch out for, it did not happen on this example, but sometimes the answer we get cannot be used in the original problem. We're going to see that a lot on 1.6 in these special kind of other equations, is you have to watch out that the solution works back in the original. There's sometimes issues. The issue that could arise here is, since you have a variable in the denominator, we can never plug in an answer that would make a denominator 0. So if I would have, by chance, had an answer x equals 1, 1 minus 1 would have made a 0 denominator. I could not have used that solution. But 1/7 should be good. The only way to know for absolute for sure is we plug it in for all these x's. Again, in the very original problem, always go back to the original problem whenever you're checking and see if it works. I don't take time to do that on every problem, but it is the purpose of solving an equation is to find x, find what works, so that's a good idea to make sure your answer works. So we'd say 3 times 1/7 1/7 minus 1. You can do that on your calculator. Minus 2 times 1/7 over 1/7 minus 1. Does that equal, plugging in x is 1/7. You're looking to see if that's true, if this makes these two sides the same answer. So I encourage you to practice that on your calculator. It's a good thing to practice, making sure you use the appropriate parentheses, you put it in correctly, and just let me know if you have any trouble doing that, because sometimes it's almost as hard to check as it was to do the algebra. All right, example B, let's do that again. Another similar, but this one's going to have a little bit different twist. Okay, so on this example B part of example 1, we've got 3 parts. That 2 is just over 1. But again, the fraction issue we're dealing with. So, always looking for the LCD to clear your fractions. There's only one type of denominator here, an x minus 2 here and an x minus 2 there, so just one x minus 2 will work for everything. Of course, 1 goes into everything, so the LCD is x minus 2, and we times that to each side. So that distributes, when I take x minus 2 times this first term, it just cancels the denominator right out and brings down the x numerator. Over on this side, distributing, for this term, x minus 2 times 2 over x minus 2, those are diagonal, so it cancels out again. Looking good there, just brings down the 2, again, getting rid of the fractions. And then lastly here, I need to use that LCD again on every term. There's nothing here to cancel it out, so I times these two parts together. And then that's the equation I have to solve. Distribute 2x minus 4. 2 and minus 4 is negative 2 plus 2x. Let's see, I think I'll bring my 2x this way. X minus 2x is negative 1x. Bring down my minus 2. Divide both sides by negative 1. And x is positive 2. It looks like great algebra, looks like a good solution, but this is what I mentioned earlier. Sometimes the answer has to be thrown out. There's some gotcha up here where, oh shoot, you can't use that answer. And this is an example of that. I wanted you to see that that could happen. I mean, it's unlikely, right? Just randomly you get the exact answer that you can't use, but it happens, so you do need to watch out for that. So the reason I cannot use 2 is I have 2 denominators that cause a problem. But notice this x minus 2, if I plug in 2 for this x and try to check it, which I say you should do that, take some time and see if it works, it does not work. I cannot plug in 2 minus 2 and have a 0 denominator. That's just a big no-no in math class, never. So if that doesn't work, what does work? Well, in this case, we had no other alternate solution. That was it. So if it doesn't work, there's no solution. We would say this is a contradiction type of equation where there is no solution to this. All right. Okay, example 2. Let's knock out these fraction ones, and then we'll move on to another type of thing that can come up. But I want to see one more example with fractions. So example 2. All of these are the same concept, so I've told you what the procedure is, but just some different varieties that can come up. All right, so if you're noticing in example 2, you have fractions again, and we have 3 fractions. So we're trying to figure out the LCD of these. We've got an x minus 2, an x, and then this last one, it's x squared minus 2x, which just so happens to be factorable into x times x minus 2. So if you see one that's a higher power or something that looks like it might factor, check the previous factors. Sometimes they've fixed it so it'll help you out there. Sometimes not though, but it just so happens this will factor down a little bit. We can factor out the x. So that's going to help because now that is actually the LCD. This x will go into that, and this x minus 2 goes into that. So that would entail one of each type of factor and where it's at the most, so it works as an LCD. So that LCD, I times to the left, and I times it to the right. Okay? And then when I distribute it, things cancel out. That's the whole idea of this LCD thing, is diagonally you should be able to cancel. This denominator should fit into that. We designed it to, so it should get rid of every denominator and make the fractions gone. So the x minus 2's cancel, but then whatever's left over, you times on to the top. Okay? Do it again to the next term. We always have to go back and use the full LCD. So if you mark something out, you've got to use the full amount again. So the full amount is distributed onto this one. The x's cancel. So you've got x minus 2 times a positive 1, or just x minus 2. And then lastly, this has been factored, so it is an exact match, and the denominator totally cancels out, just leaving this negative 2 numerator is all that's left. Okay, then we distribute, clean it up a little bit. It looks to be a quadratic because there's an x squared term. 2x and x is 3x. When I bring that 2 over, I lose my constant, so it has a 0 for the constant or c term. So how do you factor this? Well, you could use the formula. A is 3, B is 3, C is 0 in this case, but you can still use the formula if you like that method. But it is factorable. You could divide by 3 here in a couple of ways. You could factor out a 3. You could even factor out a 3 and an x. And then it is factored form now, and you can use the 0 factor property. So setting each factor equal to 0. This is going to give you x is 0 as a solution. Anytime you have a front term like this where x doesn't have a plus or minus on it, you're going to have 0 as a solution, basically there. This will change into a -1 though. And then there are two potential solutions. Again, you have to be careful because, again, the fraction thing that you have to watch for is sometimes the answers don't work when plugged back in because they cause a 0 denominator. Now, 2 would have caused a problem here, right? 2 minus 2 would have been a 0. So, but I didn't get a 2. But on this second one, I had 1 over just a regular x. So if I plug 0 in for that x, I've got 1 divided by 0, and there's a problem there. So I could not use the 0 solution. -1 is fine. Again, take some time, plug it back into all the x's in the original problem, and make sure the two sides are equal. I really encourage you to do that, at least on some of your problems, to have that skill. So if you're taking a big test, you know that's a good thing to always do. All right, so our solution is just the one answer. -1 is the one and only solution on that.